Hello, and welcome all to another new episode of the Diverseco Podcast, a series devoted to all things measurement and automation. I'm your host, Nicholas Talley, the marketing manager here at Diverseco, and I am pleased to be joined today by one of our esteemed subject matter experts, Simon Collins, to talk about the essential world of metal detection. Simon, welcome, and thanks for taking the time today to talk to our audience about the importance of metal detection within predominantly food production environments.
Oh, thanks for having me, Nick. It's going to be an interesting conversation today around one of the subject matter that I'm fairly passionate about, which is metal detection in the food manufacturing industry.
Well, before we get stuck into it, Simon, I and our audience would love to know about you and how you came to be the product inspection expert you are today.
Nick, I started probably 30 years ago in the food manufacturing industry, predominantly in the meat industry, and then gravitated to selling capital equipment about 20 years ago and focused primarily on product inspection equipment over that journey, and had a long association with the Fortress metal detector brand over that period.
So to get started, food and product safety is of critical importance to manufacturers. Now, you want your product to be safe for consumption, of course. So why are metal detectors specifically used in food production? Are there other reasons than consumer safety to utilize this inspection technology?
So you've identified probably the most critical element that drives manufacturers into implementing a foreign body detection system, Nick, in protecting the consumer. That's their primary focus of manufacturing their food. They want it to be safe for the consumer above all else. And on the back of that, they also want to protect their own brand that they've built up over the years to ensure that their product is not tarnished in any way by having a publicly recall of their product due to a foreign body, a metal contaminant being in their product. And of course, there's some cost associated with a product recall that manufacturers are looking to mitigate and minimize by implementing a foreign body detection system. So apart from protection both for the brand and the consumer, there is often other external forces that will drive companies into implementing metal detection as part of their HACCP program, and that may be compliance to either a retailer code of practice if they're contract packing for some of the major retailers, or they may be co-packing for another food manufacturer who similarly has a expectation and a specification around having a metal detector in that production line. So apart from protection of the consumer and the brand, there's also protection of machinery is another reason why some manufacturers will implement metal detection as part of their process. They want to protect downstream equipment from being damaged. So they may inspect raw materials, for argument's sake, or they may be looking to remove tramp metal or large pieces of metal that has come into their production stream to, again, protect that machinery downstream. If a large piece of metal damages a piece of equipment, they've got obviously a risk then of downtime, as well as costly repairs to that piece of processing equipment.
So you mentioned a cost associated with contaminations and recalls. How significant is this?
So the research on the costs of recalls, Nick, is not definitive, but there's certainly research suggesting that an average cost of a recall is going to be in excess of $1 million, depending on the size of the recall, the volume of product that needs to be taken off of the shelves, and how many supermarket chains that product's been dispatched to. And another cost to the business is also the impact on their brand, not only through notifications in the media of a recall of a product due to a foreign body detection, but also the fact that manufacturer has now lost that shelf space for a period of time while they recall that product before they restock it. And during that time, the consumer could switch to another brand, and then the manufacturer has lost that loyalty and that consumer. So it can have an impact on turnover as well, moving after the recall's been resolved.
When a recall occurs, are there any operational downtimes associated with the recall?
In some instances, that can be the case, particularly if it's an internal recall, so the product hasn't actually been dispatched from the manufacturer's facility. So they may quarantine that product in their storage facility, and then there'll be reworking of that product within their own facility to ensure that it is free of contaminant to be released to market. And that will necessitate having access to a production line so they can utilize an existing asset, a metal detector for argument's sake, to rework that product, or an X-ray machine. And there'll be some downtime associated with that, of course, and labor costs of manually handling that product to re-inspect it effectively before it can be released to market as a safe product.
So for both the manufacturer and the consumer, really, there are significant effects in the event of a recall.
Certainly for the manufacturer, no question, the impact on business continuity and costs and the bottom line for a recall can be quite significant.
All right, Simon. Yeah, very informative. Very informative. It might not be readily known to all, but there are different types of metal, especially present in production environments for a variety of reasons. What are these different types of metals, and can metal detectors reliably detect and identify each of them?
Nick, the types of metal that we typically talk about when we're looking at inspection equipment generally fall into three categories. You have ferrous metals, which is iron and steel. And then you have non-ferrous metals, so that covers pretty much every other metal besides ferrous: copper, brass, aluminium, lead, etc. But generally in food production, we then have a third category of stainless steel, both magnetic and non-magnetic. And that's primarily identified because, as a separate type of metal, because of the high risk of stainless steel as a foreign matter, given that most food manufacturing plants are constructed from stainless steel material. So to answer your question, it's metal detectors or electromagnetic field metal detectors can certainly detect all types and classifications of metals to varying degrees. So we'll have stronger results, say for argument's sake, for ferrous metals compared to stainless steel because of its non-magnetic properties. But all these metals effectively disturb the electromagnetic field that we've set up within the metal detector. And so therefore they're all detectable. And what the metal detector really does, Nick, is actually measures two properties of the metal. So it's measuring the electrical conductivity, so how easy does that metal conduct electricity, and also measures how magnetic is that metal. So each of those metal types will have different properties of conductivity and magnetic properties, which is why as I said, ferrous is very easy to detect, steel, because of its high conductivity, its high magnetic profile. Non-ferrous metals are typically highly conductive to electricity. That's why copper is used in electrical wiring, for argument's sake, but very low magnetic properties. So they're usually almost as easy to detect as ferrous, or maybe a little bit harder. So the test piece that we're using to verify a metal detector will be a little bit larger for the non-ferrous metals. And then finally, stainless steel, which is both a very low conductive metal and very poor magnetic, is the hardest metal to detect for a metal detector. So it will typically be, when we're looking at three test pieces for a metal detector, it'll be the largest of the three because it is the hardest to detect. But it's worthwhile noting at this point, Nick, that metal detectors don't actually search for metal, if you like, in your food product. They actually react to a disturbance in a magnetic field. So the metal detector is not hunting for metal, it's just looking for a disturbance in a magnetic field. And that can be caused by the metal, of course, but it can also be caused by a range of other disturbances in the environment.
Is it a bit of a misnomer to refer to it as a metal detector rather than a disturbance detector?
Yeah, in a sense, it's certainly a misnomer. They are a metal detector, but they do have other elements that can disturb their magnetic field and cause the machine to react. That could be, for argument's sake, vibration. It could be disturbance from a radio frequency emission from a variable speed drive, for argument's sake. You could even trip the metal detector by putting your arm through a metal detector. Even if you've got no metal in your arm, you are conductive to electricity. You've got salt and moisture in your body. You've got iron, so you're disturbing the magnetic field just with your body. So yes, a metal detector is not just looking for metal, it's looking for that disturbance in the field.
Are there typically different types of detectors to detect each metal type? Like, are some better than others?
There's typically three types of metal detection equipment, if you will. So you'll have what's called a closed loop metal detector, which is most modern metal detectors fall into that category. So you have a transmitting coil that transmits a radio frequency. You have two receiving antenna, and this wraps around the aperture that the product will go through, whether it be through a pipe, through a conveyor method of moving the product. There's older technology, which is called open loop, where you have a transmitter above the product and a receivers below the product. That technology is very rarely used now, probably more non-critical, non-food applications. So you'll still see open loop applications, for argument's sake, in quarries, mining, lumber applications, where the machine doesn't need to get down to the smallest resolution of detection. And then finally, there's a ferrous in foil metal detector, which is using magnets effectively inside the casing that's really only picking up ferrous metals or magnetic metals in a foil packaging. So if the packaging is in an aluminium tray, like a lasagna, for argument's sake, then a ferrous in foil metal detector, because of the metal in the packaging, is going to be the only metal detector that's going to provide any protection for foreign bodies in that food product.
Yeah, I was very curious about foil packed products because I mean that inherently contains metal, but there's a system specifically designed to make sure that those packaged products can be safely distributed to customers. Is that right?
Yes, in that application, Nick, the ferrous in foil style of detector will provide some level of protection, but again, it's really only for ferrous metals or magnetic metals. So if it's stainless steel in that aluminium tray, it would need to be magnetized and be a relatively large fragment for a ferrous in foil metal detector to react to that and identify it. So typically now we see in the marketplace with foil packaging that most manufacturers are migrated to X-ray technology to eliminate the packaging from the inspection and still provide very good resolution for all three types of metals, as we discussed earlier: the ferrous, the non-ferrous, and the stainless steel.
All right, so the types, many different types of metal contamination. There are different ways in which to detect them. There are different types of solutions that are fit for each requirement. So contaminations occur, and I imagine they often occur at very different stages in the food production cycle. Can you let us know about how these metal contaminations occur at different stages in food production?
Yeah, sure, Nick. Good question. Look, the sources of contaminant foreign matter can come into a number of ways. We can see it right at the beginning of the process through raw materials. So that may look like lead shot, for argument's sake, coming in meat products. It could be wire in powders. When we look to more organic products or vegetable products, you might find tractor parts or wire being presented with the raw product. It could be hooks in fish. So there's a number of raw material streams where foreign matter can come into the process. And oftentimes that's an inspection point for a manufacturer. They'll install a metal detector at goods receival to ensure the product coming into their process has already been inspected for foreign matter, or they may put that onus on their supplier of that raw material, that they inspect their product before they distribute it. So apart from raw materials, other sources can be from personal effects. That could be some of the staff's personal effects, such as jewellery, pens, hair clips, pins, and the like, which is why most manufacturers will have very strict rules and compliance around personal effects can be worn in a food manufacturing facility just to mitigate that risk. Maintenance of the production facility is another source of contaminant, Nick. So we can see after works have been done around the plant, there's a risk of swarf from any drilling. There could be welding slag if there's been any welding done around the plant, copper wire from electrical maintenance. And this is a common source of foreign body in food manufacturing. Machinery parts falling off as well, screws, washers, and the like. And then finally, probably in-plant processing is another potential source of contamination. So we have there's dangers existing every time the product is handled or passes through a process. A lot of manufacturing now is done very automatically. There's not a lot of human involvement. So anytime you've got machinery that is processing the product, there is risk of pieces of metal from that process coming into the product stream. So examples of that might be mixers, blenders, slicing equipment, etc.
Yeah, so that's very interesting. Is if there's metal detected, for example, like if you've got multiple metal detectors, would you utilize one? Like, would you use it to help detect issues with production equipment? Is that a possible application?
Typically, you would place the metal detector in the process where you're going to mitigate your risk. So identifying the potential source, as we've been talking about, those number of sources that could be generating a foreign body, so identifying that potential source is a vital stage in developing an effective metal detection program, safety program. So typically a manufacturer will undertake a thorough risk assessment of their entire production facility from paddock to plate. And then they'll identify their potential sources and then look to mitigate that risk. And that may be like, for argument's sake, acquiring raw ingredient suppliers, as I mentioned, to implement a foreign matter inspection program themselves. So once they've identified the sources, they've tried to mitigate the risk, then they will install metal detectors and other foreign body inspection systems just to monitor and control that process. And that will usually be underpinned by a hazard program, hazard analysis, critical control point program that the quality team have implemented to identify those risks and then how they can mitigate those risks through control points.
So that sort of leads very nicely onto to this next question, which would be to combat those contaminations along certain critical control points. Where should you install metal detectors in food production lines, and why? I mean, I'm sure that some might think the answer is everywhere, but I imagine along those critical control points, wherever they may be, would be the prudent way to go.
Yeah, no, you're right, Nick. That's generally the way most manufacturers will approach that process as part of their food safety program. So there's various stages in the production process where you can implement an inspection process. That would typically look like one of three main areas. So you'd have bulk inspection, where you're inspecting the product, the food in the process. That is generally going to be looking for, say, larger foreign bodies before it gets fragmented. So if a bulk process is then going to drive that food product into a grinder, say in a meat application, so pre-grinder, pre-mincer, you'd like to maybe inspect before that process so that if there is a large piece of metal, it doesn't go through the reduction of the next stage and perhaps get fragmented into smaller pieces of metal that will then contaminate a broader section of production. The other advantage of doing an in-process bulk inspection is your product's going to be typically a smaller burden height, so a lower height of product across the belt. And therefore, when we put a metal detector around that lower product height, we're going to improve our detection accuracy. So it actually can offer you superior detection capabilities. So the other reason you might look to do that is to protect that processing equipment we mentioned, whether it be a grinder, a mincer, a pelletizing machine. You'll want to protect that equipment from being damaged by the foreign matter in the production flow. So if we move them from a bulk in-process inspection before we've actually packaged the product, well then typically now the optimum place to install a metal detector is going to be on that finished primary packaging. Once the product is put into a package, a tray, a pouch, a bag, then there is now no risk of any subsequent contamination from the process. It's sealed, and that's the optimum place for inspection. And generally, you're going to find, Nick, that from a compliance point of view with the most major retailer code of practice, that's where they're going to specify the optimum place to install that metal detector. So that becomes, for most manufacturers, their critical control point is finished primary pack inspection. So once we've taken it from a primary pack, we can then, most manufacturers are going to put that into a tertiary packaging, so into a shipper, a carton. And that's another opportunity to capture some inspection with a metal detection, because you're going to then inspect for large foreign metal that's found its way into the carton, perhaps pre-sealing. So not so much for consumer protection, because each individual packet is sealed, but it's a further inspection point for any large metal that may have come into the packaging. And Nick, what we see is some of our more mature users of metal detection will actually implement inspection points at all three of those positions along the production line. So they'll be inspecting firstly at the bulk flow application prior to packaging They'll then inspect the product in the finished primary pack when there's no more risk of contamination getting into the product, and then they'll also inspect on dispatch in the carton or tertiary packaging.
So there are different critical control points along a production line. When contamination occurs at each of these control points, the further along the production cycle that a product is and a contamination occurs, do they have different consequences on the manufacturer? Is it better to catch it early?
Yeah. Look, that's a good question, Nick. And in that sense, the answer to that in short, it will be yes. So I guess if we think now about inspecting raw product, let's use chicken nuggets as an example. So if we're inspecting raw chicken nuggets just come out of the freezer, loose on the belt, we've got a nice low metal detector slung across that conveyor. It's going to have very good detection performance. We're going to pick up a nugget or two with a small fragment of metal. The reject mechanism is going to then reject that product in a small volume. So there's less volume, less waste, you could say, in terms of the product that's now been quarantined, compared to if we let that chicken nugget flow into a vertical form field seal machine. We've now put it into a bag. We've printed some data on the bag, some expiry dates, etc. Then we inspect it and reject the bag. We've now rejected maybe 1-2 kilos of product, so there's more product waste. We've also added value to the product, so now you're wasting packaging, printing, etc. So from a cost perspective, the primary pack is going to be more of an impact on the business than doing the product before it's been packaged. And if we extrapolate that out now to downstream, where we're going to put 10 of those bags into a box and inspect the box and reject the box, then again, you've added more value, you've added time, and you've now got to rework that product. You've got to pull those multiple packs out of the shipper, run them through your metal detector to identify which packet's got the contaminant in, and then again reduce that packet down to find the actual nugget that's got the contaminant. So there's a lot of rework, there's a lot of labor costs, and that's probably what you're going to see as you move down the inspection chain, more costs in terms of loss of packaging, wasted time and cost to the business in reworking compared to doing it upstream.
Yeah, that makes a lot of sense. So not every production line is the same. Not every product profile is the same. So with that in mind, are there certain industries or production environments that more commonly use metal detectors? Or is this really a matter of if you have a food production line, you need a metal detector?
Well, certainly if we're focusing on food manufacturing, it's commonplace in industry now to implement as part of your food safety and quality systems a foreign body detection system. And still, despite the advent of newer technology over the last 10, 15 years in X-ray, metal detection is still the cornerstone of most manufacturers' food safety and quality program. They're used broadly across a full range of manufacturing, from meat, poultry, seafood, through bakery, dairy, confectionery and snacks, ready meals, milling and ingredients, and on and on. So it's basically anybody manufacturing food that's going to end up on the supermarket shelves, going direct to consumer, then a lot of those manufacturers will be implementing a food safety program that includes metal detection through electromagnetic field metal detector. Certainly outside of food manufacturing, we do sell metal detectors into some non-food industries such as plastics and textiles. So inspecting rubber components, paper bags, whether they be paper bags going into the supermarket to pack your groceries in, or paper bags that are going to say have milk powder or flour put into them. So we'll inspect those type of products for metal contaminant, as well as agriculture as a big user. So hay, stock feed and the like is often inspected with a metal detector to protect their end user, which is going to be a thoroughbred racing horse or a cow. Mining and quarry is another user of metal detection, lumber industry, personal hygiene. So there's a very broad application for metal detection in a lot of different industries, but certainly in my experience, 90 to 95% of metal detectors that go into the marketplace are heading into the food industry.
Okay, so if that's the case, that 95% are going back to food manufacturers, how much of an impact because it's all about sort of the conductivity and the ability to detect not specifically metal, but something that would impact the electromagnetic field, how much of an impact do wet products have on the ability for a metal detector's accuracy and function? Like dairy, meat, fish. Is there a difference between them and something like fruit, vegetables, or baked goods?
Yeah, Nick, certainly the conductivity of the product, as you mentioned, calling it wet, is one of the key factors that limit the sensitivity of any metal detector. And typically in industry, we use the phrases dry and wet to describe a product's constituents and its ingredients and its profile to a metal detector. And typically what we're saying really is conductive product is wet, so it has salt, it has moisture, so therefore it will conduct the magnetic field and disturb that field. And then we have products that are what we call dry, so they're non-conductive. So think biscuits, chocolate, flour, milk powder and the like, no free salt and moisture. And those products will have, the wet products will have a significant impact on the sensitivity of the metal detector. But there's other limitations that affect a sensitivity on a metal detector. And the first one is the type of metal, as we've already touched on, whether it's ferrous, non-ferrous or stainless will have an effect on the sensitivity. Also the orientation and the shape of that metal. So in metal detection validation and verification, we typically use a sphere as the test piece because it has no orientation or shape variance. So we can do a repeatable test. But in the real world, of course, foreign bodies don't come in spheres usually, and that's usually going to be a wire, a swarf, a twisted piece of metal. And that orientation and that shape will have dramatic effect on the capability of the metal detector to detect it. So apart from the type of metal and the orientation of that foreign body, then we can look at the packaging as another factor that will limit the sensitivity of a metal detector. So that may be if the packaging is a metallized film, or as we mentioned earlier, foil packaging. This is going to have a detrimental effect on the capacity of that metal detector to operate at its optimum settings. What we've seen in the marketplace over the last 5 years is most of the leading manufacturers have developed specific technology to overcome those effects of metallized film, specifically by using simultaneous multi-frequency instead of the traditional single frequency technology. So that's been an advent that has overcome some of that negative impact of the packaging on the performance of the metal detector. And similarly, that technology that we speak of there, the simultaneous multi-frequency technology, can also overcome some of that product effect characteristics that we mentioned, the wet characteristics of the meat and the dairy product. So simultaneous multi-frequency as a technology can both suppress product effect to a greater extent and also overcome some of the detrimental effect of the metallized film and deliver more reliable detection in terms of reduction in false rejects and improvement in sensitivity capabilities. And apart from that, probably the two major other areas that will limit the sensitivity of a metal detector, Nick, would be the actual aperture size of the metal detector. So invariably, the smaller the aperture, the better the performance of the metal detector. And the larger the aperture, it's going to be diminished in its capabilities of detecting smaller fragments of metal. So that's going to play into whether, again, we go primary pack inspection versus tertiary pack inspection. So on a primary pack, we can have a smaller aperture, get smaller capabilities in terms of the sensitivity of the metal detector versus a tertiary pack where we're going to a larger aperture to accommodate a large carton. And the trade-off of that, of course, is the sensitivity is going to be diminished. And that kind of plays into whether you go for a custom-built solution versus a mass-produced off-the-shelf metal detector as your preferred solution. A custom-built metal detector from a manufacturer that builds machines specifically to order, like Fortress Technology, our supplier, will invariably outperform a off-the-shelf mass-produced machine that only comes in limited aperture sizes, where if you can wrap your aperture around the dry products here so it's closer to the packaging size, then invariably it will perform in a superior detection levels compared to larger apertures that are just off the shelf. And that can have an impact on the performance, as I say. So for argument's sake, if we're talking a metal detector that can get 1.5 millimeter stainless steel, if we can reduce that performance by having a smaller aperture down to say 1 millimeter, then although that's only a 30% improvement in diameter, it's in terms of the mass of metal in that 0.5 millimeter, it's actually a 70% improvement by going down to 1 millimeter. So there's some significant improvements in brand protection, consumer protection in your food safety program if you can optimize your aperture to suit your packaging. And finally, Nick, inspection speed and the environment will have an impact on the sensitivity of any metal detector. So a blow line, for argument's sake, where the product's moving at very high speed, will certainly have a detrimental effect on the performance of the metal detector. And similarly, when we look at the environment, if a plant has temperature fluctuations, for argument's sake, that fluctuate throughout the day or from season to season, then that will have some impact on the sensitivity of a metal detector. And then when we talk about environmental impacts in the actual plant itself, that can be a source of compromising sensitivity, and that may be a source from airborne electrical interference, so radio frequency emissions in the environment. It could also be vibration of the plant and the equipment around that metal detector. Those elements can limit, again, the sensitivity.
Great. Well, thanks for enlightening us on the topic of metal detection, Simon. It's been very insightful, and I've really enjoyed having you on this episode.
Well, thanks for the opportunity. I've enjoyed it too, Nick. Pleasure chatting with you today.
Well, thank you all for joining us today for this episode of the Diverseco Podcast. If you'd like to learn more about what we discussed today, feel free to reach out to us. And for more content and episodes of the podcast, and if you would like to reach out to Simon via LinkedIn or email, you can find a bunch of helpful links in the description of this video. Take care, everyone.